Hey everyone, in this video we are going to understand about the first in first out page replacement algorithm. Okay, and we'll understand this with the help of a example. So let's start. So we have already discussed what is page replacement and why do we need page replacement algorithm. So if you have not watched that video, you can find the link of that video in the operating system playlist in the video description below, or you can find the link here in the I button also. So let's understand our first page replacement algorithm, that is first in first out, or the FIFO page replacement algorithm. So in any of the page replacement algorithm, we will be given some of the things and we will be asked something. Okay, so what is the things that we are given with? We will be given a string or group of page number. That group of page number will be called as reference string. Okay, and another thing that we will be given with is how many number of frames are allocated to that process. Okay, and we will be asked that we have to find how many number of page faults are generated with CPU reference or ask for these page numbers. So let's understand what is the meaning of this reference string. Okay, so let's assume CPU actually generated different virtual addresses at different point of time for a particular process. Okay, so let's say CPU generate a virtual address 0102. So you can assume these are like the hexadecimal numbers. Okay, 0x, all these are the hexadecimal numbers where the first 2 byte they are telling me the page number and the last 2 byte they are telling me the offset. So this is P and this is D. So in that sense, this 0102 is telling me that CPU is asking for the page number 1. 01 in decimal is 1, right? Now 0200, that means the CPU is actually asking for the page number 2 and the 0th byte of the page number 2, right? Here the second byte of the page number 1 was asked, right? So this is actually page number 2. Okay, I have written this page number 2. The same way, this is asking for the page number 3 and the 40th byte. Okay, 40th byte of that page number 3. So this is page number 3 actually. Okay, same way, this virtual address is asking for the page number 4. This is asking for the 1. This is asking for the page number 2, and this is asking for the page number 50. Okay, so here it is actually 50, and this is asking for the page number 1. Okay, and the 4th byte of that page 1. Okay, so actually in our page replacement algorithm, we will not be given this thing. Okay, these virtual addresses we are not given with. We are actually given with this group of page numbers. Okay, and this group of page number is called a reference string. Okay, these are the different page numbers which are referenced or which are asked or demanded by the CPU at different point of time for a given process. So why we are given only these page numbers and not the full virtual addresses? It is because, let's say CPU asks for the this virtual address. Okay, so CPU is asking for the page 1 and the offset is 02. Okay, so in this process map, okay, this is the process. So that means we are asking for, or the CPU is asking for the page number 1 and the 02 byte, that is the second byte. Okay, second byte inside page 1. Okay, now this means the second page number is asked and the 0th byte is asked. Okay, second page is asked and 0th byte. Okay, the offset is 0, so 0th byte is asked. So this is the virtual address that was generated. So as you know, when CPU asks for a virtual address in form of P and D, then inside the page table, what is searched? Mapping corresponding to a page number is searched. And when mapping is not present inside the page table, then page fault is generated. Okay, so that means only this field, that is P, that is page number, is sufficient to tell me whether page fault will be generated or not generated, and after that page replacement algorithm will be applied or not, right? So there is no need actually for this offset. Okay, although at last we want the second byte, we want the 0th byte, but for our working of the page replacement, just the P value or the page number value is sufficient. Okay, so here you can see when the page number 1 was asked and the second byte was asked. Okay, so okay, this is page number 1. Now after some time, you can see the second page was asked, third page was asked CPU, then fourth page was asked, then again first page was asked. Here the 4th byte is asked. Okay, so whether the CPU is asking for the second byte or the 4th byte, it is actually asking for the page number 1 only, right? So that means we are actually referring for the page number 1 only, right? So page fault will be generated for this also, no matter what we are asking for which offset. Okay, so that's why in the questions we will be given these group of page numbers only, which will be called as the reference string. We will not be given this full addresses, right? So this is our reference string or the group of page numbers which are asked at different point of time by the CPU for a given process, and the number of frames which are allocated to this process are 3. Okay, and we have to find the number of page faults. So let's apply this FIFO algorithm and see. So I have written this reference string again. Okay, now here you can see we are given 3 frames for this particular process. Okay, so in the coming videos we will be understanding a topic, frame allocation to process. That is how it is decided that how many frames will be given to each and every process which will be coming inside your main memory. Okay, for the time being you can just understand that for each and every process which wants to come inside the main memory, some particular number of frames will be given to that process so that it can execute. Okay, on the same thing, 3 frames are allocated to this given process. Okay, and we have to put all these pages inside these frames only. Okay, so these are actually the main memory. Okay, this is actually the main memory, and these 3 frames we have to use. Okay, so let's apply this FIFO algorithm. So what is the idea behind FIFO algorithm? We will understand. Okay, so here you can see CPU asks for the page number 1 for the first time. Now for the first time, all the main memory will be free. There will be no page inside this main memory. So for this page number 1, page fault will be generated. Why? Because inside the main memory it is not present, right? So we will be keeping this inside any of the free frame available. Okay, so I will start from here. Okay, up to down I will fill this way. Okay, you can fill down to up also. Okay, so what it means, I will place 1 here. Okay, so you can keep 1 here also. Okay, now let's say CPU asks for the page number 2 at different time. Okay, after some time it asks for the this page number 2. Now OS will check inside this main memory. Okay, actually OS will actually check the page table. Okay, via that only it will be getting to know that inside main memory whether that page is not or present. Okay, so we will be directly seeing that main memory. Okay, for our examples. So this page 2 is again not inside this main memory. So what will happen? Page fault will be generated. Page number 2 is asked. Okay, but I will do 1 is already here, so I will place 2 in the new frame. Okay, this is the free frame. Okay, I can keep here. I can keep 2 here also because this is also free, but we will be going via definite steps so that we can come to know that how many number of page faults are generated. Okay, otherwise it will be like a random algorithm we can place at anywhere. So we have 2 page faults till now. Okay, so I am writing this take. Okay, take means page fault is generated for that given page number. Now for this page 3, we can see this page 3 is not already present inside the main memory. Okay, so again page fault will be generated. So I have this free frame 1, 2, and now I will be placing 3 here. Okay, so for 3 page fault was generated. Now we come to the page number 4. So here you can see inside the main memory the page number 4 is not present in any of the frame, right? So what will happen? Page fault will be generated. Okay, for 4 page fault will be generated. Now the question is, when page fault is generated, OS will bring this 4 from the hard disk to this main memory, and it will try to place this 4 inside any of the frame. Okay, but all the frames are full which are given to this particular process P1, right? So where should I place? I cannot place anywhere. I should go via a page replacement algorithm. The FIFO algorithm will actually tell me which page should be selected from this frames. Okay, so FIFO algorithm says replace the oldest page, that is the page which came for the first time, or which is the oldest page which came inside these frames. Replace that page. Okay, or you take that page as the victim page. Okay, so here you can see the first page that arrived in these 3 frames was 1. Okay, 1 came at the starting, then 2 came, then 3 came. So out of these 3, 1 is actually the oldest page. So when 4 is to be kept inside this main memory, then which page should be selected according to the FIFO? This 1 page should be selected. So in place of 1, I will keep this 4. Okay, so 1 will be going in on to the hard disk swap space, and 4 will be kept here. So what I will do, I will cut here and I will say 4 will be kept here. So that means 4, 2, 3 is my new content of the frame. Okay, the same way Now I will go for the 1. So 1 is searched here. 1 is not present. So again for 1, my page fault will be generated. So what I will do? Again, I will select a victim page. So what is the page that should be removed or which should be replaced? So here you can see out of 4, 2, 3, which is the oldest page. So here you can see the 2, 3, 4. These are the pages, right? So 4 is just brought back just currently. 3 previous to 4. 2 is the oldest page, right? 2 is the oldest page out of these 3. So actually this 2 should be replaced. It is the victim page. So 1 should be written here. So now 4, 1, 3 is my new content, right? Now let's check for the page 2. So page 2 is again not inside any of the frame. So it will create a page fault. Okay. Now which page should be selected as a victim page? So again the oldest page. So this 3 is the oldest page. Okay. It should be actually selected. Okay. According to the FIFO algorithm. So here I will keep 2. So it is 4, 1, 2. Right. Now page 5 is reference. Page 5 is searched here. Okay. It is not present. That means it will generate a page fault. Okay. So which page should I replace actually to keep 5 inside this free frame? So which is the oldest page out of 4, 1, 2? So if we just check, 1 was the first page, then second was brought, then third, okay, then fourth, then 1, then 2. Okay, so in that sense, if we see out of 2, 1, 4, 2 is just use, 1 was just reference, 4 is the oldest out of this 4, 1, 2. So 4 should be cut and 5, 1, 2. This is the new content. Now 1 is reference again. So if we check for the 1, we can find this 1 here. Okay, 1 is already present inside the main memory. So its page table will say, okay, it is already present. It is mapped to the frame number. You can say this is 0th frame, this is first frame, this is the second frame. Okay, it is mapped to the first frame. Okay, so it is already there. So no page fault will be generated. Okay, so you can see this can be called as page hit. Okay, that means page is found inside the main memory. Now let's check for the page number 2. So page number 2 is already inside this main memory. Okay, so no page fault is generated. We have a page hit. Okay, now let's check for the page number 3. So page number 3 is not present here. So it will generate page fault. So FIFO algorithm will select a victim page. So which page should be selected? So here you can see 1 should be selected because this is the oldest out of 5, 1, 2. Okay, so here I should keep this 3. Okay, this 3. So it is 5, 3, 2. Okay, when we ask for the 3. Okay, now 4 is not here. Okay, so it will generate a page fault. Okay, so 4 is asked. Okay, so which should be selected as a victim page? So this should be selected. Why? Because out of 5, 3, 2, this is the oldest. Okay, 5 is 5 was referenced, 3 was referenced just now. Okay, 2 is the oldest page. This came first. Okay, here oldest means the page which came first. This you have to take care because when LRU will come na, here you have to take care which is the oldest and what is the meaning of the first. Okay, this came first actually. So 2 is replaced by 4. Okay, so my new content will be 5, 3, 4. Now last page is 5. So 5 is already present inside this main memory. So there will be no page fault. Cut. Okay, this is page hit, right? So here you can see how many number of page faults are generated at different point of time. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 page faults. Okay, total 9 page faults are generated. So this is the answer for number of page faults generated by the FIFO algorithm. So this way FIFO algorithm will be replacing the pages, or it will be finding the victim page and it will be replacing those pages. Okay, so I hope you have understood that how this algorithm works, and if you have not understood, please rewind this video. And again, if you have any question or query, please write down into the comment box. I will answer them. So in the next video, I will be taking another example with new reference string. Okay, and we will be seeing that how again we can apply the FIFO algorithm on that given string. Okay, so see you in the next video, and please like and share this video, and do not forget to subscribe the channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.